Okay, in this video we're going to take a look at problems 94 through 101. We're going to be running a matched pair t-test between x1 and x2. And we want to know if there's evidence to suggest the means are different. So if you recall earlier, we put x1 in list 1 and x2 in list 2. Let's just verify that. So turn my calculator on. If I go to stat edit, I can see I have my two lists, right? List 1 and list 2. Those are x1 and x2. Now, I want the difference in list 3. I'm actually going to run a one sample t-test on the difference. Okay. Remember that in matched pairs, the groups are dependent. Usually it's either a post-test, a pre-test, and a post-test on the same group of people, or there's some closely relation. So, let's see. So let's go to second quit. And the way we do the save list 3 as a difference between, let's say, list 1 and list 2. Well, here actually I told you to use x2 minus x1. This way we all get the same answer. So we're going to make list 3 to equal list 2 minus list 1, right? Because this is x2 and this is x1. All right. And this is going to be the difference. All right, so back to my calculator. We're going to type in, let's do second stat, and go down to list 2, minus second stat, and go down to list 3. I'm sorry, list 1, second stat, list 1. There we go. And if I hit enter, now you'll notice that it returns a list of the differences. But I want to store that, so I click store, and I want to store that as list 3. So second stat, list 3. Okay. And there's my differences again, but now I can access it list 3. So it wants to know what is the mean of the differences. So really what we're going to do is we're going to run one variable stats on list 3. So let's go ahead and do stat, calculate one variable stat, and let's change this to list 3. Second stat, list 3. All right, so here, this gives me my x bar, which is the mean of the differences. So round to decimals, that's going to be 0.43. In the next problem, 95, it says what is the standard deviation of the differences. So I denoted it S-D for standard deviation of the difference. And again, the calculator showed that as well. That's the SX. 3.69, 0. So two decimals would round to 3.69. All right, on the next slide, 96, we want to calculate the test statistic T. So recall, it's the same thing we did in the previous problem. You got T equals, and we do the difference of x bar minus mu divided by S divided by square root of n. Okay. So here, let's just take a look at what our hypotheses are. So we want to know about the difference. So the null hypothesis, when you're doing a difference, is going to be that the mu equals 0. Again, this is mu difference now. I was calling it mu d, I think, right? So we're saying that the average difference is 0. And then for the alternate hypothesis, we're going to do mu not equal to 0. Also note that this is then a two-tail test. All right. So the test statistic is x bar, which we just calculated. Let me pull that up. All right, so x bar was, the mean difference was 0.43. Okay. So T equals 0.43 divided by the standard deviation, which we got to be 3.69. And then we go ahead and divide that by the square root of n. Well, n was still 7 in this case, right? So square root of 7. and we get 0.31 for our test statistic. All right, problem in question number 97, again, we already showed that we were doing a two-test tail. That's because the alternate hypothesis was mu not equal to 0. All right. And you want to find the p-value, so 98. So remember that for the p-value, it's going to be the area of the tail. So a two-tailed test, we have two tails. Because the normal distribution is symmetric, the probability in each tail are equal, so we can just find the probability in one tail and multiply it by 2. So this was 0.31 over here, and this, of course, was negative 0.31. And our p-value is the area in the tails. And again, these two areas are equal, so the p-value is going to be 2 times the area in the right tail, or 2 times the area in the left tail if you wanted to. Now notice that degrees of freedom is 6, that's n minus 1. And we need to pick an upper bound, so we'll use 100 again. So we're looking for the area, 2 times the probability that t is between negative 31 and 100. So let's just pull up the calculator and show how we do that. Okay. So again, we can go to second vars and go down to TCDF, and we use 0.31 now for our lower bound. We'll use 100 for our upper bound. Degrees of freedom is still 6. I'll go ahead and paste that in, and then multiply it by 2. And you could have done 2 first. It doesn't matter. Either way, if we round this to 2 decimal places, you're going to get your 0.77. So this is your p-value. This is the combined total of the area and the tails. And this is going to equal 0.77. So now we have to compare that to our level of significance. So in question number 99, it says, do we reject the null hypothesis? Well, again, if it's not given a level of significance, we just assume it's to be 0.05. So 0.77 is much greater than 0.05. So again, this means that we fail to reject the null hypothesis. The null hypothesis is that they were the difference was 0, which means there was no difference between the means of the two groups. So do we reject the null hypothesis? That would be yes. I'm sorry. We failed to reject the null hypothesis, so do we reject the null? No. And then the next question, is there evidence to suggest the means are different? And that again would be no, because we're failing to reject that the mu difference is 0. So that means they're not different. And in the last problem, it just asks, is the matched pairs t-test, are the groups x1 and x2 independent? So again, these are the same people or very related people that are matched together. So the answer is no, they are not independent, they are dependent. All right, and my daughter's here. She wants to tell you all something.
Hi, everybody. Good luck on your final exam.
All right, thanks. Stay tuned for the next video.